Welcome to Pre-Calculus Chapter 3. In this chapter, we're going to look at exponential and logarithmic functions. We've got it broken here into 5 sections. We'll probably just have time to squeeze in 4 of them this year. We'll start today looking at 3.1, exponential functions and how their graphs look. And then we'll do the inverse next, the logarithmic functions and their graphs. 3.3 we'll look at the special properties of logs, and in 3.4 we'll look at solving different types of exponential and logarithmic equations. If we do have time for 3.5, that's just real world type models that fit these type of functions. So here we go, diving into 3.1. What is an exponential function? We're used to seeing stuff like x squared, where the base is the variable and the exponent is some real number. Now we're going to turn that on its head. Now our base, we'll use letter A to represent some number. Now our exponent is the variable. So the exponential function f with base a is denoted by f of x. A is our base, x is the exponent. A has to be a positive number, and a cannot equal 1. X, the exponent, can be any real number, so we can see stuff like 3 to the root 7. We could see 4 to the sine x power, all kinds of different combinations with exponential functions. Here in example 1, we're just going to do some calculator work. I'm going to use my calculator here on my laptop, and there's different keystrokes for the different calculators that I have in the classroom. But what we have here is f of x is base 2 to the exponent x, and we're going to make that exponent negative 3.1. Now the way the book describes this here is f of negative 3.1, or 2 to that exponent. If your calculator has the up caret key, it's just real simple, 2 up caret negative 3.1, and hit enter. But if you are stuck using your calculator on your laptop, let me get this so it fits in the window. We've got this key here, x to the y power. First, we're going to put in our base 2. We hit the x to the y power. Notice here we got the 2 up caret. Now we're going to put in the 3.1 exponent, make it negative, enter, and we get this decimal. We'll take it to 4 spots, 0.1166, and there it is. Oops. Next, we've got 2 to the negative x power, or x is going to be pi, so that's 2 to the negative pi power. Let's see here, so we'll do 2 x to the y power. Now our exponent, we're going to make that pi, and they do want it to be negative pi, and enter. 0.1133. There it is. Up next is 0.6 to the 3/2 power. Now, instead of doing the 3 divided by 2 there in parentheses, 3/2 is a nice easy one to turn into a decimal. That's just 1.5. So 0.6, oops, wrong again. 0.6 to the 1.5 power, 0.6, x to the y. 1.5 is our exponent. 0.4647. And there it is. Again, the calculators in class will have different keystrokes, and we can do some of those for practice. All right, in example 2, we're going to check out the graphs of some of these exponentials. In example 2, we're going to look at 2 to the x and 4 to the x, and we're going to do those in the same set of coordinate axes. I'll do 2 to the x in blue ink. Now here on the table, I like to start at 0, because if we put in 0 for the exponent, 2 to the x becomes 2 to the 0. Anything to the 0 power is 1. And let's put in the whole number 1. 2 to the first power is 2. 2 to the second power is 4. All right, now let's do the negatives. So I would have 2 to the negative 1. Remember, negative 1s means just we can move that to the denominator. So that's the same thing as 1 over 2 to the first. So this would be a half. And now if we go to x is negative 2, that would be 2 to the negative 2 power, or 1 over 2 squared. 2 squared is 4. Up next, negative 3. 2 to the negative 3 is the same as 1 over 2 to the third. 2 to the third is 8, so that would be 1/8. And if I go out one more on the positive x-axis here, if I put in 3, 2 to the third power is 8. Notice here that we have reciprocals. 0, our output is 1, but here we've got 2, and it's reciprocal. The next one out is 4, and it's reciprocal. Oop, that was supposed to be a 1/4. Sorry about that. 8, flip it over, 1/8. So there we can see that relationship on the table around 0. And let me fix this. I bet you were yelling at your computer screen when I was making that mistake. 1/4, there we go. Let's graph those points. Back to blue ink. So we had 0, 1. We had 2 to the first was 2. 2 to the second was 4. 2 to the third was 8. And now we go into the fractions. -1, that was a half. -2, that was a fourth. -3, that was an eighth. Notice we're getting very, very close to the x-axis. The farther out we go to the left, the closer we'll get, but we're never, ever going to touch the x-axis. So I'm going to fill these in. That's pretty darn good. All right. So that is 2 to the x. I'm going to switch to red ink, and let's go back and do red ink for the... No, it's not going to let me do it. Dang it. We'll do red ink for the 4 to the x power. Again, at 0, 4 to the 0 is 1, because anything to the 0 power is 1. 4 to the first power is 4. 4 to the second power is 16. Let's do 4 to the third. We won't be able to graph it, but that would be 64. Now, if we do go to the negative side of 0 here, that's going to be 4 to the -1, or 1 over 4. 4 to the -2, or 1 over 4 squared. 4 to the -3, 1 over 4 cubed. And again, we can see that reciprocal relationship, 4 to a fourth, 16 to a 16th, 64 to a 64th. So some of this graph is going to be the same. Definitely the y-intercept. We're also going to cross here at 0, 1. But our next one will be over 1 up 4. And then over 2, we would have to go up 4 squared is 16, so that would be off the graph. And then as we start heading to the left of the y-axis, our first point here would be a fourth, so we're under that blue dot. And then a 16th, we're under that blue dot. We're going to get pinched in there. And let's see if we can do this one. All right, good enough. The red one there is 4 to the x. Notice over here in the second quadrant, we're approaching the x-axis as we head toward negative infinity. And as we head out toward positive infinity, our graphs are growing exponentially steep. And yeah, that's it for example 2. Here's a couple for you. You know the drill. Pause the video and try these out. And then start the video back up and see if you got them right. All right, if your calculator button pushing went well, this first checkpoint should have been 0.0528248. And then for here, we got a couple we're going to graph. I'm just going to hop over here to my graph. Here is 3 to the x, I'll do in red. 3 to the 0 is 1. 3 to the first power is 3. 3 squared is 9. Over here, we would have a third, a ninth, a 27th. So we're going to come off the x-axis, go through 0, 1, and then we're up and away. And then I think the other one was 9 to the x, 9 to the x. This one's going to grow up real fast. 9 to the 0 is still 1, but 9 to the first power is 9. If we went over to 9 to the second power, we'd have to go up to 81, and our graph only goes up to 10. So this is rising very, very fast. But we are going to cross at the same y-intercept, and over here the blue graph will be under the red graph. And that's pretty good for a sketch. What's next? Now, basically the same graphs, but now it's 2 to the negative x and 4 to the negative x. Again, I'm going to blue ink here. We'll do 2 to the negative, and then we're going to put numbers in these parentheses. So if we put it in a 0, 2 to the 0 is 0. Negative doesn't apply to 0. It's neither positive nor negative. But now let's go to the left first here. If I put in a -1, 2 to the -1 is just 2 to the first. That's 2. If I put a -2 in there, 2 to the -2, that'd just be 2 squared, or 4. Now if we go over to these positive numbers, that would be 2 to the 1 power, so that would be our 1/2. We put a 2 in there. 2 to the negative 2 power would be 1 over 2 squared, or 1/4. And up next would be 1/8. And I just realized I was supposed to be doing that in blue ink, but oh well. So let's graph this one. We had our 0, 1. Whoa, that's my highlighter tool. 0, 1. When we went to -1, we were up to 2. -2, we were up to 4. If we did -3, we would have been up to 8. And now over here we have our 1/2, 1/4, 1/8. So now as we go left to right with this graph, we're sort of heading down toward the x-axis like we're coming in for a landing, but we're never going to touch down. 4 to the negative x is going to be similar. 4 to the negative something. See, 4 to the 0, that's 1. Negative side, negative first is positive, so that'll be 4 to the first, and then we'll have 4 squared. Now let's just do that reciprocal property. So if this is 4, on the flip side will be a 1/4. This is 16, flip of that will be 1/16, and our next would be 1 over 64. We are always multiplying that denominator by 4. 4 times 4 is 16, times another 4 is 64. So again, the y-intercept is the same, but now at -1, we're up to 4. At -2, we would be up to 16, which is well off the graph. So this one's going to come in like this. And then we'll have our 1/4, 1/16, 1/64. Again, our blue line will be under that red one. And remember when we were doing graphing stuff, here we put a negative in front of our variable. And remember, that is a flip across the y-axis. So if this is our 2 to the x, 2 to the negative x is just flipped over the y-axis because we negated that variable exponent. Now this, the one-to-one property. Let me just state it like this, put a little quote here. If the bases are the same, you can set the exponents equal. If the bases are the same, you can set the exponents equal to each other. So number 9, or letter A here, is a nice easy one. We've got 9 equals 3 to the x plus 1 power. The right side has a base of 3, so we would like to write the left side as some base of 3. And 9 is 3 squared. So we can write 3 squared is equal to 3 to the x plus 1 power. Now we can utilize the one-to-one property. The bases are the same, so I can set this exponent equal to this exponent. Last step, subtract 1 from each side. X is equal to 1. You know, and this is an easy one to check. If we throw the value we just found in right here, if we make that x into a 1, it becomes 3 to the 1 plus 1 power, which is 3 squared, and that does in fact equal 9. Now letter B here, there's an interesting little property that these exponents have. Maybe you remember it from an earlier section. But we can flip this fraction over if we change the sign of the exponent. So this 1 over 2 is going to become 2 over 1, and now the exponent changes signs, and that's equal to 8. And now that we've got a base 2, how can we rewrite 8? 2 to the third power. So one-to-one property says if these bases are the same, we can set this exponent equal to this one. And to get x to be by itself and to be positive x, we would divide both sides by a negative. X is -3. So there's the one-to-one property. All right, a couple for you to try here. So pause the video, give them a shot. I have faith in you. All right, in this first one, our right side has a base of 2. Let's rewrite 8 as 2 cubed. And that's now equal to 2 to the 2x minus 1 power. Bases are the same, so let's set these exponents equal. 2x minus 1 is equal to 3. Let's add 1 to each side. 2x is equal to 4. Divide by 2, x is 2. Letter B. Now this one, we've got our fraction in the parenthesis, and our exponent is already negative. So when we flip this side over to 3 over 1, this negative x is now a positive x. And we can rewrite 27 as 3 to the third. Bases are the same. Let's set the exponents equal. And as soon as we do it, the show is over. X is 3. And that's the end of the video. We're going to do some odd problems in class. Look for the assignments on your second favorite website, WebAssign. And I'll see you in the next video.